In a county, 51% of the adults are males. One adult is randomly selected for a survey involving credit card users. Part A. Find the probability that the selected person is a male. Well, simply put, 51% of the adults are males, so if we let M be the event that the randomly selected person is a male, then the probability P of M is 0.51. And that is it. We do not have any other information than that. 51% of the adults are male, so the probability that we randomly selected a person and that person is a male is 0.51. Part B. It is later learned that the selected survey subject was smoking a cigar, so we know something about this selected subject. Also, 9.5% of males smoke cigars, whereas 1.7% of females smoke cigars. Find the probability that the selected subject is a male. If we don't read the question carefully, then the last sentence, it might seem similar to part A, but it is not. We're asking to find the probability that the selected subject is a male given all these informations here. So this is the conditional probability because we're looking for the probability with a condition. We will use a tree diagram to solve this problem, but we will let the event of smoking a cigar as C for cigar. Then we summarize these numbers in symbolic form. 9.5% of males smoke cigar, meaning if we know that the person is a male, the chance or the probability that he smokes cigar is 9.5%. So this is the probability that the person smokes cigars given that that person is a male. And 9.5% is 0.095 because 9.5% is 9.5 divided by 100. And so the conditional probability P of C given M is 0.095. Similarly, 1.7% of females, so out of all of the females, 1.7% of them smoke cigars, and that itself is a conditional probability as well. This is the probability that the person smokes cigar given that that person is a female, where we use M for male and F for females. So this is 0.017 because 1.7% is 1.7 divided by 100 or 0.017. Now we can find the probability that the person selected is a male. And so we're looking for P of male, but given that we know that that person smoked cigar. Again, this is the conditional probability. This is the conditional probability P of M given C, not the same as P of C given M. Because of the given information where we know something about the gender, given male, given female, so the first stage in the tree diagram has to be selecting a male or not a male, which is a female. Again, that is the first stage. We then write the corresponding probability for each of these outcomes. 0.51 chance or probability of selecting a male, therefore 1 minus 0.51 is 0.49. The probability that the selected person is a female is 0.49. Then comes the second stage. The second stage is whether the selected subject smoke cigar or not smoke cigar. And we do this for each of the previous outcome from the previous stage. So smoke cigars or not smoke cigar. For the second stage, we will have the conditional probability. Given that the selected person is a male, the probability that he smokes cigars is 0.095. And therefore, 1 minus 0.095 is 0.905. That is the probability that the selected male does not smoke cigar, 0.905. Given that the selected subject is a female, the probability that she smokes cigars is 0.017. And 1 minus 0.017 is 0.983. So this is 0.983. Remember that every time we use the tree diagram, the sum of all of the probabilities from the branches coming out from the same point need to add up equal to 1. And this is why we take 1 minus, 1 minus, 1 minus. We're looking for the probability that the subject is a male given that that subject smokes cigar. From the conditional probability, we have, this is the probability of M and C, probability N in the numerator divided by P of C. We can use the lengthy Bayes theorem to rewrite this formula, but since we use a tree diagram, all we need to do is to collect all of the outcomes that end with C, and that is the C in the denominator here. There are two ways that leads to the outcomes of C, 1 and 2. The sum of those two probabilities will give us the number that we will use in the denominator. In the numerator, we simply follow the branches that connect M and C, and that is the first branch. And so the probability of M and C equals 0.51 times 0.095, and this is 0.04845. In the denominator, the probability of C is 0.51 times 0.095 plus, that is the first branch. And then we still have another way to get to C here, and that is 0.49 times 0.017. And if we do this in a calculator, we will get 0.05678. And so to answer this question, the number in the numerator is 0.04845 divided by the number in the denominator is 0.05678. And this is approximately 0.85329, about 85% chance.